Hello everyone, we are from SABER team Smart Optimization of Building Energy. With our team, the first one is from Machine Learning team. There is Dian, Haikal, and Jingga. And from Cloud Computing team, there is Rafli and Alfahri. And from Mobile Development team, there is Michel and Aldi. And the first one is the background. Nowadays, Indonesian population electricity use increases. There is two sectors. The first one is business, and the second one is industry. In business, electricity used by business customers in West Java in the first semester of 2023 reached 4,036 gigawatt hour, an increase of 22.1% compared to the previous year. In industry, electricity used by industry increased sharply by 10.5% from the previous year to August 2021. What are we trying to achieve or solve? We are trying to develop an integrated smart building energy optimization system that utilizes advanced IoT and machine learning technology to address the pressing issue of carbon emissions from buildings. Why we build this up for this project? To help reduce the impacts of carbon emissions and reduce company costs. What our app can provide to users, our application not only provides electricity consumption monitoring services, but we also provide features such as interactive dashboards, electricity usage predictions, and daily reports. We also have IoT and smart devices integration products.
And in the reasoning, because this increase in electricity use has a big impact on the company and the surrounding environment. And the second is efficient management of electricity use can help companies save on electricity costs and reduce environmental impacts, such as global warming, acid rain, and waste of energy resources. And in existing results, we found several apps similar to ours, such as MyEco and PLN Mobile. Some of the missing elements we identified in the application were the first is the application cannot provide IoT products that are integrated with machine learning. And the second is the application does not provide the real-time electricity consumption monitoring information. And we have evaluated various competitors in this market, such as MyEco and PLN Mobile. Our analysis focused on key technological capabilities that are pivotal to our smart building energy optimization system. And this is our competitors.
And the next one, implementation and result. And the first one, IoT blueprint. In the IoT blueprint, we are using two sensors to measure the currents and the voltages. And then we calculate the power by that two parameters.
The next one, we will be talking about our dataset that we use on our final model. So we use the dataset from archive.ics. It is individual household electric power consumption. On the dataset, we use three sets of data. It is date, time, and then submetering tree. The next one. And on the machine learning architecture, the dataset we obtain from the dataset, we pre-process it and then we train it using the RNN model using LSTM. After that, the model we optimize it and convert it to TensorFlow Lite so we can use it on the mobile app.
Next, we are diving into the architecture of our web service. In constructing this service, we leverage various services provided by Google Cloud Platform. At the development stage, we utilize Node.js and Express.js framework. To store data, we make use of Google Cloud Storage and Firestore serve as our database. Now, when it comes to deployment, we adhere to CI/CD principle, employing Google Cloud Build. This service is configured to automatically deploy each time we push changes to the main branch in our GitHub repository. For deployment, we are using Cloud Run to act as a platform where our service get deployed. Through Cloud Run, users, whether on mobile or IoT devices, can send requests via a URL, exchanging data effortlessly. Next. In the next segment, let's delve into the API documentation. For our service, we are using OpenAPI to make the documentation. Our API includes features like creating a new user account, user login, fetching user details, submitting electricity usage, and getting the average power usage for the current day or the past 24 hours. For more information on how to use each endpoint, please visit the URL provided in the image. Next. Okay, so next, let's talk about the source code of our service. The entire code base is available on our GitHub repository. To explore further access the documentation, head over to the GitHub repository using the URL provided in the image. There, you'll find all the details you need to understand, contribute, or even set up our service on your own. Thank you.
As we mentioned before, the data has been retrieved from the cloud will be consumed from the API. The process will be handled by retrofit. The retrofit will handle configuration and services of the API. After that, repository is the next for the host of the data. Repository will distribute the data with the use cases to view models. Another important role for this part is independent injection by Hilt or Dagger. It really helps in injecting constructors, parameters, or context. Then the data will be displayed and arranged into widget by Jetpack Compose. But we are not stopping there. The data will also be processed by Tablet that is implemented in Android. And then next, we're going to jump demo result and improvement. So as we jump into the user journey and user flow, the first thing that you're going to see is the login and sign up. If they have an account, they will be asked to sign up first, and then they will log in. This is an important part for them to connect with their installed IoT devices. And after logged in, they're going to be directed into the dashboard of IoT. The dashboard of IoT is divided into two segments. The first one is power consumption. And there we can see that there's like a filter date and there's like a monitoring charts that can be used to monitor the electricity usage by selecting the date above. And then under that, we can see the export data. The export data will be used to save the data from the current date. And then the product consumption will be used to provide information such as total of the electricity consumption, and then the average, and there's also analyze and predict. Here, the analyze and predict will be implemented using the template from the model created by the machine learning before. And then next, the profile. There's also a profile screen to display the data information of the user, and there's also services from the app. And the next.
Okay, this slide, you can see the documentation for this project. If there is an overview and program of the project. And then you can also access the project by click the link provided.
Okay, and this local deployment. Next, okay, in the target market, several target market goals that we went to aim for. First, professionals and decision makers. Second, the age range of 30 to 60 years old, unless sustainability managers and operation directors. Next, in the BMC, this is a view of our business model canvas for MVP and the vision. Next, in the budgeting plan, this is what our fund location will look like and the budgeting plan. Next, in the sustainability. In sustainability, our source of income from MVP is IoT product sales amounting for 1,500,000 per product. And in the future, there will be use fee and subscription fee. Our efficiency practice run with minimal operations, reduce unnecessary costs, choose appropriate third-party service and vendors. Based on 10 million budgeting, the expectation is that it can run for 1 year and reach 6 company with some of the asset with the profit. And we can move on the future plan.
Okay, so the last one, we will gonna talk about our future plans. And this is what our timeline looks like. We have 6 milestones. We start from January 29, and it involves market analysis, system installation, site selection, operation, content development and deployment, system configuration, and lastly, performance evaluation and strategy development. And lastly, this is what our upcoming features we will develop. The first one is smart device control. Second one, alerts and notifications. And the third one, reporting and analytics. And lastly, we will be developing the smarter models.
That's all from us. Thank you for your attention.